So first off, let's see if our mics are interoperating with the audio system. And first off, I want to define what that means. So give a brief introduction. I'm Chris from Cosmos. I work on research and specification of the IBC protocol. Give a brief introduction of your project. Explain, in the context of your project, which entities are interoperating, how they're interoperating, and why. No more than 2 minutes each. Mark.
That's quite a challenge. Agoric is building a level of abstraction that we think of as the next level up above blockchain. We're building a platform for expressing distributed smart contracts that operate across chains, both between different chains and including non-chains, both public and private. We're building it in a object capability security foundation, which we'll come back to. We're building it initially in the JavaScript language, but we're keeping the fundamentals of it language independent. We're building an object capability subset of JavaScript, and the nature of our smart contracts are much more interoperable than the smart contracts you see elsewhere in the industry. In order to operate across chains, we identified a set of problems that were very similar to the problems that motivated IBC. As a result, in trying to solve those problems, we ended up designing a set of solutions we called VATTP that turned out to be very similar to the solutions designed by IBC. And when the two groups realized that they had come to similar conceptions of what problems to be solved and very, very similar solutions, we decided to merge efforts. And we just did that over the last 2 days as to the final realization that we can merge these efforts and together be building one protocol.
Hi, I'm Alastair. This is right now.
Yes.
I'm with the Web3 Foundation. I'm working on the design of Polkadot. So Polkadot, like Cosmos, it's a heterogeneous multi-chain solution. Comparatively, it's a bit more complicated. We want to have a more trust-free interaction between chains with shared security, shared state, shared code where possible. So the sort of vision is that we're going to be able to treat a smart contract on another chain or something almost as if it was on your chain. Right? We should be able to operate as so Polkadot should operate as one system. We also want to be able to talk to other chains, right? If I thought there was going to be one chain or even one ecosystem, I wouldn't be here. And interoperability is just making these things work together as best as possible.
So it sounds like everything interoperates in Polkadot. The machines interoperate, the chains interoperate, the contracts interoperate, and Polkadot interoperates with things that aren't Polkadot. Is there anything that doesn't interoperate?
If so, we want to make it interoperate.
All right, got it.
I feel like I get to double dip here. So I want to focus on a different level. Our target is not just the use cases in the room, but the use cases that everyday programmers have, with the goal of bringing the entire world's economy online, not just mainstream economy, but all the ways that people cooperate, and supporting that in a decentralized fashion. And that means that one chain isn't going to do it. Everyone in this room isn't going to do it. We need millions of programmers to be doing this stuff. And so it's not plausible to me that one chain could possibly solve everyone's problem, even if everyone was behind it. Now, we all know that's not the way that innovation works. We all come up and create new things. And so, we're starting with Cosmos because we're so aligned on how they interoperate. We've been working with the Polkadot folk, and so we expect to interoperate with both those systems. But more fundamentally, we expect to enable lots of people with lots of use cases out there interoperate with each other. That's the goal.
Great.
Yeah, this is working.
Yes.
Okay. Yeah, so I slept in the Charles de Gaulle airport last night while I snuck on here. But I'm Jehan Tremback, and I work on an application actually called Althea. It lets people create decentralized ISPs. So my perspective on interoperability is more, I guess, more pragmatic, or that's what I'm dealing with, is kind of the pragmatic level. So number one, our customers need to be able to use like dollars to transact. They don't want to use some kind of weird token. Some early networks had to use Ether, and that causes problems with the price going up and down and stuff. So what we use basically is DAI, but people have to buy it as Ether, and then turn it into DAI on Uniswap, because it's easy to buy Ether everywhere. And then we're going to be bringing it on across to a Cosmos chain. But right now we're using XDAI, so it's like that's like my perspective. So like it's hard to use the Ethereum blockchain because it's very slow. So we need to bring a token that originates on the Ethereum blockchain across onto a faster blockchain.
So speaking of a diversity of applications, or maybe running on a diversity of networks, I want to talk a bit about security. If we have a wonderful diaspora of emerging applications built by many different people, those of us who build those applications know that many of them are unlikely to be perfectly secure the first time around, the second time around, or maybe even the 10th. So when we build these complex interoperable systems with densely connected graphs of all these different entities, how do we contain failures? How do we ensure that if one part of the graph fails, it's contained or limited in a way such that it doesn't bring the whole system crashing down?
There's a core security principle that goes back to very early days when people started reasoning about security, called the principle of least authority. And that is that an entity at any level of composition, an entity that is supposed to do a particular job, has a legitimate job it's supposed to do, should only be given approximately, at least the authority needed to do the job, and approximately only that. Very little authority beyond just the minimum needed to do that job. And to the degree that you approximate that, you did not give it the excess authority that enables abuse. And that principle happens at every scale, at every level of composition. I'll take this as the opportunity to come back to object capabilities. Object capabilities gives us a very natural way to express least authority. The other main security paradigm, which is identity-based access control, that Ethereum, for example, practices with message.sender as the access control mechanism, that paradigm under composition has two failure modes. You end up with a loss of expressivity because something that you wanted to allow, you find yourself unable to allow because it inhibits delegation. Or you find yourself in excess authority that in order to allow what you wanted to allow, the entities involved had a lot more ability to cause damage if they went wrong. So the first thing is limit the damage that a buggy entity can cause. The next thing, which we're also, we see starting with object capabilities and object capability programming languages, is as essential, is to enable programmers whose expertise is not on smart contracts, whose expertise is elsewhere on their subject domain. Enable them to write smart contracts with confidence to make the programming of smart contracts much less hazard prone. And the security properties of the object capability paradigm are very close to the modularity properties that we already understand in object-oriented programming, so any experienced object-oriented programmer can already leverage the understanding that they have and extend that understanding to form an intuition about how to reliably write secure programs.
Right, so still very loud. So where possible, we want to just avoid having trust. This was like some of the idea behind blockchain in the first place. And so we want there to be no model where you have to trust something on another. If another chain has the same security model, that makes it easier. In Polkadot, we can have ways for change to share code in a modular way. so that you can be sure that you're talking on one end, the code you're talking to is talking to a thing with exactly the same code. But inevitably, you have a system like this, there is going to be something that goes wrong on some component that's not going to be isolated. You're going to have problems. And you need a way to recover from it. So you need a sort of governance system that's going to mean that when something does go wrong, you can fix it.
So human intervention will always be necessary.
Yeah, there's no way that we're going to get this thing automated and make it actually right the first time.
Prior to blockchain, security and selling security was always fairly thankless. Because what would happen is people would need some function, and they would implement some function in a way that utterly compromised their network or their application or what have you, but by gosh, they got that feature out the door. And then the security people are coming along and apologizing for reducing the actual functionality because that's not safe, oh my gosh. And the crypto environment is, from a security point of view in many ways, so hostile as to be much better for security practitioners to participate in, because when code rolls out, if it's got a bug, and this happened many times, bam, tens of millions of dollars lost in minutes with no recourse, right? And so that means that unlike the traditional application environment where you can have a security failure, which you apologize for and promise you won't do it again, and then move on. Here, it's worth actually innovating. It's worth actually paying attention. And so there's a lot more awareness and acceptance of security, and security is something that people realize adds value, where there's things you won't do unless you have a security practice that enables you to do so safely. And that's really precious, and I think it has a independent of all the other ways that blockchain might move the world forward, that's a huge value in moving the world forward to live in a environment of software that is actually safe and not easy to corrupt from halfway across the world. It's worth pointing out that least privilege shows up there, where now what we're bringing is, instead of restricting what people can do, we're saying, okay, here's facilities so you can provide people the authority they need to do their job, and here's incentives to make sure you actually know what that is. And so I think as we go through that, we'll end up with a lot more secure systems, and the compositions will be secure. The last thing I will point out, though, is security is one of those places where reinventing everything from scratch is not the right answer. There are security practitioners out there where, we've already got some amount of security code reviews that people have been doing for 20 years, only here, my God, it really matters. There's tens of millions of dollars on the line for any one bug in any one of these systems. And so it is worth, setting aside any kind of presumption that you know what that you're doing, and make sure to find the security people out there that can actually think about this stuff, because they can bring real value as opposed to just scaring people.
I actually want to talk about something that's been on my mind lately with security as relates to interoperability. And this is not like bugs or like vulnerabilities per se, like where someone makes a mistake and there's some vulnerability in the system, but actually the incentives of the miners and validators on a given chain. So if you have like a chain that's got like its food chain, it's got food coin on it, and the validators decide, hey, you know what, we're going to take 2/3 of the validators are going to take the 1/3 of the validators' food coins away from them or something. Normally that's like not really a viable attack, because everyone's going to be like, wow, well, food coin is obviously a terrible chain and its value is now down to 0. But if you have a chain where you've got assets on a bridge on another chain, and that bridge is effectively controlled by the validators, it's a whole different ballgame. Because if you've got, let's say you've got $10 million in DAI on a bridge to Ethereum, or maybe to another type of blockchain, and the validators on the blockchain that is on the other side of that bridge, that basically controls that Ethereum locked in there, they decide that it's worth more to them to actually steal that $10 million than it is to continue validating on the chain. And that could be, obviously, probably the original people who started the chain aren't going to do that themselves, but it could just be some whale coming in and buying up enough of the coins that they can actually get that money out of the bridge. And that's a pretty difficult problem, because for us, we want to have our own chain because we like the sovereignty of it as an application developer, and also you're able to get more fees. So our token holders can get all the fees from our chain by well, most of the fees except for the cut the validators take. But the flip side of that then is that there's less security. So that's a tough kind of tough road to walk. Like how much do you want to give transaction fees away to other people, and versus how much security do you want? So
It's an excellent question, and I think the problem is more general, because the same kind of verification necessary to facilitate interoperability can be turned around, or so to speak, and used as a tool for verifiable bribery. If I can interoperate between Ethereum and Cosmos, or between Cosmos and Polkadot, or between XDAI and Ethereum, I can use the same code that I'm using to check whether transactions need to be relayed between Polkadot and Cosmos to, say, pay the validators of Polkadot on Cosmos, or vice versa, the validators of Cosmos on Polkadot, to do something that I want, to act in a Byzantine manner, to censor a transaction, to vote for a particular block so that I can double spend and buy 2 Ferraris when I'm only paying 100 Bitcoin. Is that a risk? Is it an insurmountable risk? How do we mitigate that?
So I'm not going to answer the particular question, but rather frame it with regard to how to view the variety of security questions that we're confronting simultaneously. The normal way of reasoning about secure computing, the things that I generally refer to when I talk about computer security, are much more discrete. A system either has an exploitable vulnerability or it doesn't. And then with blockchain and with the new industry that we're in, there's this whole new level of game theoretic risk, of whether things can be gamed, of whether a given arrangement of incentives is strategy proof, as it's sometimes referred to, whether the reason we thought it was strategy proof did not take sufficiently into account side payments and coalitions. And just like the other kind of security, computer security, has a mathematical basis that we can refer to reason about, so does game theory. Unfortunately, unlike computer security, actually deriving safety results from a sound game theoretic analysis is, for almost anything interesting, really beyond what we can do. So the other methodology that's very important is experimental economics, is games, is adversarial games. And we saw a bit of this with Cosmos putting together the game of stakes, where the point was to try to do adversarial playtesting against the Cosmos staking system. There was not enough adversarial testing in that, from what I understand of what happened. But it was definitely pointed in the right direction. There's been some good work in economics in trying to create systems to do experimental economics with grad students in artificial settings. And there's a lot understood about the methodology there, about what to watch out for, what the threats to validity are, what the scaling issues are with regard to small-scale experiments, talking about large-scale economic issues. So there's this whole new field of adversarial playtesting of game theoretic constructions to supplement what little formal analysis we can do. And that's really at a whole other plane than what we mostly talk about when we talk about computer security, and this industry has to confront both of those.
So perhaps we need adversarial cross-chain testnets, where we have incentives on Polkadot and Cosmos and Althea and Ethereum's Rinkeby all at once. What say you?
Well, so I would like to distinguish, I generally distinguish when a new challenge comes up because of some innovation between created problems and revealed problems. Often people go, oh my God, this thing's happening, right? There's now this problem. And the answer is, no, you always had that problem. It's just now obvious that you have that problem because of the innovation we brought you. So the cross-chain thing, I didn't hear anything about interoperability that created a new problem. Yes, now I've got yet another mechanism to go bribe the validators. But the bribe the validators thing was always there, right? And so the question is, what's actually new there that interoperability needs to address? And what are new tools that interoperability can bring to bear to address not just the newly created problems, but the ones that were revealed that already existed?
Another thing. Okay.
Yeah, so this will happen. Someone's going to try this. So it'll be fun. And the economics of it, we don't know. I'm a theorist, and I think we should we don't know what the attacks are going to be, so we're just going to have to, and we don't know what the out-of-system incentives are going to be. The best we can do is to say that within the system, it's going to cost you a lot to attack. And in Polkadot, we want to make it so that you attack the entirety of Polkadot in order to do anything. That's going to be so expensive that hopefully no one outside can put enough money behind it for it to be possible. But yeah, we can already do this with one system with smart contracts. But across systems, it's very much harder to analyze.
So it sounds like we always have to draw a line, right? We have some topology of interacting systems. We can draw a connected shape around this closed system we want to analyze, and analyze the incentives within that system, but there could always be outside incentives. Maybe the difference now, insofar as interoperability has changed the nature of the bribery problem, it's simply expanded the size of the connected closed systems we can draw.
I would say the revealed problem, I suppose, with the example I gave of validators stealing from a bridge is that up till now there hasn't been a lot of value secured by blockchains, which is not intrinsic to the blockchain securing value. So this problem could have shown up years ago if people had started actually, let's say some of those early Bitcoin supply chain projects had taken off. There could have been a similar incentive to corrupt the Bitcoin miners by somebody who was trying to short, let's say, a large shipping company back in 2009 using the Bitcoin blockchain for supply chain. If they had done that, it would be the same thing as stealing from a bridge, as an example.
Yeah, the bridge thing is big. It's really hard to. You want to make sure you don't trust the bridge operators, and that's fun, but possible.
So speaking of bridges and network topologies more broadly, let's run the clock forward a decade, more than that, too speculative. Run the clock forward a decade, assume that we succeed in both the current projects we're all engaged in, and in the project of interoperability more generally. What do we expect the network topology to look like? Is there going to be a single TCP/IP style protocol that connects all the blockchains? Are there going to be many interoperability protocols operating horizontally that connect different parts of the graph? Are there going to be interoperability protocols stacked vertically that connect different levels of user operation, like layer 2, layer 3? How will it look?
So there's an important sense in which that's easy. TCP is not a thing all by itself. There's TCP and RSVP for media there, and all the thing, SMTP layered above that, and protocols on top of SMTP to do more things, and HTTPS. Everyone's stacked every other protocol that existed on TCP onto HTTPS and so forth. And so it's hard to imagine that it's anything other than that. Right? There's no one protocol that is the solution to all things. They'll have different trade-offs in the performance space, in the service space, and in the latency space. All the micropayments versus macro payments. How much assurance you have versus is it on my light switch? And so so I think any lesson we've learned of how to do heterogeneous systems, we should have in mind. We should keep in mind, because that's where the world has to go.
Right now, we're sure that there are going to be a lot of standards. There are a lot of projects trying to do their own interoperability. So there will be a lot of standards initially. We're at the experimental end, right? We're coming up with new stuff.
The nice thing about standards is there's so many to choose from.
Exactly, and that's going to be the case. And then what's going to happen in the long run? Well, we'll just have to see. There's several ways this could evolve. There could be one standard that wins, or there could be several.
Yeah, there were all kinds of, in the history of networking, there were all kinds of weird network protocols that people did for decades, and for TCP/IP. So we might still be in that phase for decades to come.
Yeah, and I don't think you necessarily come out of that phase like TCP did with one dominant winner. I think that one of the key things about the kind of interoperability we're building is that for any one thing that you're building, assume that there are others solving similar problems differently. And that includes any bridge technology that you're building to cross between these things. So what really counts is not whether we all agree on one protocol, but rather whether these things can bridge and window into each other so that to the users, they get end-to-end connectivity despite all of the differences in the protocols that are getting them across each hop to get from one end to the other. An example where we just don't even notice the heterogeneity anymore is some machines are big endians, some machines are little endians, some protocols are big endian or little endian. These used to be tremendous debates. People had strong feelings about big endian and little endian. Nobody even notices that the big endian, little endian systems are interoperating because the higher levels of software have completely masked those differences. We're going to have multiple different systems masking the low-level differences, bringing us end-to-end connectivity. Once we have that, maybe from that cauldron something will emerge as dominant, but at that point it doesn't make any more difference than one endianness emerging as dominant.
Another interesting example is that from networking is that Ethernet actually evolved independent of IP. And so now, of course, if you are familiar with networking at all, Ethernet will be like connecting the computers in a single building, and then IP connects computers over the internet. And actually they both have their own strengths. So we could have a similar kind of thing where you have maybe groups of blockchains connected by one more homogeneous interoperability protocol, and then expanding across those groups of blockchains with more higher level interoperability protocols, for example, like IP over Ethernet.
How do you think the addition of a in-protocol incentive layer has or will change the economics of how protocols develop? I wasn't really around when TCP/IP was being developed. I'm a bit too young, but you were. And I'm curious as to whether, no offense.
Thanks, Chris. Thanks.
And I'm curious as to whether you think that is there an additional dimension in how these protocols can name the actors within their protocol, create some kind of scarce token, pay them in different ways? Or is it kind of same old as the economics inherent in building physical computers to talk TCP/IP?
So it is a little bit different. One of the things I was going to add on your prior question that partly answers that is, we've been excited to work with ICF and partner with ICF on IBC stuff, where one of the things we bring is, I don't know that I was around when IP was, I was probably barely around. But I learned from people that had been around. How's that? That we get to bring the experience having solved some of these problems before pre-blockchain. And many of the questions and the things that you only realize are hard when you actually get there. You can go through and design a protocol and then you go, oh, flow control. Or error handling, does that terminate the stream or not? And these are the kinds of questions that the first time you don't discover it until you're in production. The second time you discover it when you're in beta and oh crap, you need to recover, right? The third time you try and incorporate it into the design early. And so some of the stuff that historically people have had to solve as challenges, we need to answer those questions. Let's not discover those in production again because it's too expensive. But blockchain does bring some new things to the table, or rather, really deeply thinking about having payments as part of the process brings some new things to the table, where now instead of just wanting flow control, I can do rate control because you're paying for more. And that's more general, it's more powerful, you can implement other things out of it, and it's not necessarily slower. And so there are some, real innovations possible as a result of the different environment. There were some pre-blockchain protocols that looked at that stuff, and it's worth bringing their ideas forward because there's a good chance that while their answers might not be the ones we come to, the questions are the ones that reality brings, and it's worth having those surface.
I think that one of the interesting things about the sudden emergence of the need for lots of incentives stitching a thing together by bringing about composable self-interested activity that follows the invisible hand, is the sudden emergence of it creates something that's different than what historically has been a major aspect of the robustness of markets, which is competition with reputation feedback. And the emergence of trusted intermediaries, or somewhat trusted intermediaries, by virtue of a long history of trustworthy action that causes this gradual accumulation of this form of capital, which is the willingness to take a risk on whether they will misbehave or not. I think that it's very interesting that we found ways to bootstrap without having to wait for that slow accumulation of trusted intermediaries. But I do think as our industry matures, we are going to see the emergence of some of those. And computation reputation feedback still creates a emergent robustness with regard to the misbehavior of any one, but we'll find that the connectivity of relationships that are enabled by such competitive trusted intermediaries will solve some problems that are difficult to solve otherwise.
I'm actually a bit worried that all this hacking of incentives we're doing. So, for assumption like almost majority, that's very nice and composable, but incentives, they're not really, because we have this complicated game theory argument that means that if we're paying incentives in one part of the system, this might completely overwhelm the incentives in the other part. And trying to get a system like this running just on incentives is quite hard. But when we have this, we can come up with some clever ways to pay people for doing their part in an anonymous thing that you just couldn't do otherwise. And so maybe we will have use for things that we just couldn't pay for otherwise.
So for the last question, I want to pivot a little bit. I was struck yesterday looking at a photo from the protests ongoing in Hong Kong over the extradition law to China of subway users queued up in front of a physical ticket machine because that accepted cash, because they didn't want to use octopus cards, which could be tracked by the government. Can we integrate privacy into our interoperability protocols in ways that preserve the verifiability we need across these different chains or contracts which are interoperating, while also preserving the privacy provided to end users that they need out of these systems?
I am hopeful that we can. Zcash is both a technical example of that, but also they have consistently and successfully gotten out the message that it's not just individuals that need privacy, but businesses to do commerce need privacy. And that's something that in terms of navigating the regulatory maze and navigating mainstream sensibilities, investor concerns, all those kinds of things, business, cooperation, collaboration needs privacy. And so, I'm not quite sure whether we can, but I think a lot more people respect that we should. And that'll make a difference in terms of combining these things to be able to maintain or indeed leverage one of the things, a reason to interoperate with some of these other chains like Zcash is I can move stuff over there and do some private stuff and then move the assets back, in a mixed style that lets a chain like Cosmos, some of the Cosmos zones or Polkadot, what have you, leverage the fact that Zcash has this additional shielded activity and use it for personal and business purposes.
What about privacy at the network layer?
Well, I think that privacy at the network layer, ultimately, well, so if you look at Tor, for instance, Tor mixes things up a lot, and it bounces things around a lot, and it slows things down, although you get privacy that's, I think, pretty provably private with Tor. Now, when you're routing packets on the internet, otherwise, you kind of need to know who is trying to send what where in order to get it there. So privacy on the network layer is pretty nuanced in that a lot of the time you can't have exactly the privacy that you want, and there are performance trade-offs to get privacy, and that's just the way it is. The other thing is though, so as it relates to our system, Althea, Althea doesn't really provide privacy, complete provable privacy, but if you want that, you can easily use Tor on top of it. So I guess my perspective from like a networking perspective is more that it's important to be able to layer protocols to let people get the functionality they want. At the same time, I do wish it was possible to have a system that was private but also fast, but that's just really difficult because inherently, you're mixing things around. So that's just the trade-off that exists.
Right, and Tor isn't perfect, right? You can still link the timing.
Yeah.
Between sending and sending. We need to slow it down even more to make it so that it's indistinguishable. We're working on that. People are working on that.
I actually think with blockchains, and I'm not an expert on this stuff at all, but I think with blockchains, there's a lot of computational work that has to happen with zero-knowledge proofs, but I think that stuff actually might be easier to optimize than network traffic privacy. So I'm pretty hopeful, and I think that what you really need is not just a private zone or transfer it to Zcash and then do something private, because then people are going to ask, what were you doing that was so private there? It's kind of weird. It's better if it's
right.
legitimate
the anonymity
business.
set even for transactions you don't care about anonymizing.
Exactly. It's better to have it so it's like always on, and then it's kind of unquestionable. It's like, well, that's just how it is. Would you want everyone seeing your transactions? No, so it's private.
Yeah, I remember there was a beautiful analogy back when people also used paper to communicate. Hopefully people have enough memory of those days or heard about them that they'll understand the analogy. In a world where almost everyone communicates with postcards, the guy who uses the envelope raises a red flag. So if you want to make it safe for people to communicate with envelopes, you need to use envelopes even when a postcard would have served your purpose.
But yes, we want to have privacy things on one chain interacting with less private things on other chains, hopefully through enough interaction that you can't tell what's going on. Part of the problem is that some of the things we'd like to do, like bridges, I don't know how to do a private bridge. You can have a private thing on this chain, and you can have, if we want to bridge to Zcash, as far as I know, there's no way of doing that privately and accountably. So you'll be bridging to the unshielded part, which is fine. But in principle, it's possible.
So we have a lot of work to get the privacy we all want.
We do. All right. For one last one-sentence answer question, in which I'm going to abuse my position as moderator by asking a question I wouldn't want to answer. How long do you think it will take for all the systems represented on this panel, IBC, Agoric, Polkadot, Althea, to interoperate with each other in a significant fashion?
So I'm sorry, I'm not familiar with your system, so it's hard for me to state an estimate that answers the full question. With regard to the others, I think we'll have demonstrable interoperability quite soon. And I think that that will turn into interoperability of those systems and many others, perhaps including yours, once these things get going, the markets are all about network effect. And once you've enabled it to start happening, it will create a demand for greater end-to-end interoperability because there's such a strong network effect dynamic to markets.
And hopefully, 1 to 2 years.
1 to 2 years.
If we don't do it in 2 years, it won't be my fault. That's the aim.
So the challenge for us on here is to do it within a year.
Within a year.
That's
Yeah, I guess my perspective, so yeah, just to reiterate, Althea, it's like basically it lets routers pay for bandwidth so people can set up decentralized ISPs in communities. But my perspective on interoperability is more like as an app, like it's an application, like we use a blockchain, we're not like making a blockchain. So my perspective is just that we want to use whatever's best. Right now, to us that looks like Cosmos. That being said, if there was a big group of other blockchain projects that were all interoperating, but there was some kind of problem where Cosmos was not interoperating with that whole conglomeration, we'd probably find that it would be a good idea to actually switch over to one of the blockchains that was interoperating better because it is a network effect thing, you're saying.
So I'd have to say that then it's entirely on Chris to make sure that you're able to interoperate within a year.
Oh boy, oh boy. All right, well, whenever it happens and however it happens, I'm looking forward to interoperability. Thank you.